Hello everyone and welcome. In today's video, we are going to be discussing about Optuna and how we are going to be and how we can use Optuna in hyperparameter tuning. So a quick search about Optuna. So this is their website. So with Optuna, it gives you techniques or it's easier for you to optimize your optimization. So it's just an open source hyperparameter optimization framework to automate the hyperparameter search. So when you just do a quick search about Optuna, you'll get to this website and you can just go through what Optuna is all about. So in terms of installation, because this is a library you are importing, so you just do a pip you just do a pip install onto your Jupyter notebook, and then it will install the Optuna library, and you will be able to recall it or call it when you are doing the hyperparameter tuning. So basically, this is what you're going to be using. So I'm going to show you how we can typically use Optuna for hyperparameter tuning. I'll deal with a problem that involves regression, and I will also tackle a problem that involves classification, so that we are able to understand how we can apply this library. Okay. So with that much said, let's get started. So as usual, you're going to start by importing the libraries. So import the libraries. For the libraries, I'm going to import pandas as well as import numpy as np. Then after this, we then move on to import the dataset. So for my dataset, so we will be using a diabetes dataset. So for this dataset, we are tackling a classification problem. So as you can see, our column outcome has two classes, 0 and 1. So if you just, for example, let's see the unique values under the column outcome. So when we look at the unique values, so we have 0 and 1. So this is a binary classification. So we are trying to, for example, predict one if a patient is suffering from diabetes, and 0 if the patient is not suffering from diabetes. So this is a classification example that we are going to be tackling. So for data summary, so I just want to check if, for example, if I'm missing values. So df.info, when we execute this cell, you can see that we have a total of 768 entries. Okay, total of 9 columns. And we are not missing values from our data frame. Okay, one data cleaning step is about duplicates. So when we execute this, when we're looking for duplicates, they are using the duplicated method. You can see we don't have any duplicates. So I'll move on to import the necessary modules, such as the classification algorithms and other modules that will be necessary for this analysis. Okay, so I will be using a random forest classifier and maybe an XGBoost for classification, and I'll also use the same for regression or maybe other algorithms to see how we are going to be applying this. Okay, so let me import those. So the random forest, so from scikit-learn ensemble going to import random forest. Random forest classifier. Also, we'll also import the train test split. So the train test splits for classification. Also import the standard scalar. Also import the standard scalar for our metrics. So maybe I will import for evaluation metrics. So say from scikit-learn dot metrics. Going to import resi. Let's just import the classification report. Classification report. Okay. So those are the libraries or the modules that we are going to be using for this analysis. So after this, we can then random. It's supposed to be random, but random. Just a spelling mistake. Random forest classifier. Then train test split standard scalar classification report. In case we encounter, we'll import other modules as we go by. Okay. Then after this, we can then define the variables. The variables as well as the target variable. Say the input variables and the target variable. Then after this, we can then say use the common x and y. So x, so df dot drop. So just drop the target variable from the input variables. Just do columns. Then we say so our input or our target variable is the attribute outcome. So I'm just going to pass in that column. Then for our y, which is the target variable, so I'll just again pass in that attribute. Okay, and execute the cell. Then from here we move on to doing a split test, splits to training and testing. So xtrain, x test, xtrain x test, y-train, xtrain x test, y-train, y-test. Then from here, we use the train test function. So no, the train test split. So train test split. So x into the brackets, our y, we pass in our arguments. So the test size. So test size say 0.2. The random state is the seed value. So random state we say 42. Okay. Use an arbitrary value. Then after this, we move on to scaling. So I'll first create an instance of the standard scalar. So scalar, we can do a standard scalar. We create an object of the standard scalar. So standard scalar. Okay. Then we fit and transform the training data. Xtrain scale, so that this is a variable that will store our scaled training data. So we just recall the scalar, then scalar dot fit transform. Fit transform, that's okay. Then we just pass in that training data, train. Okay, so we can just repeat the same for the testing data, but that we're just using the same scalar, but we are not fitting and transforming. We're just doing a transformation. Okay, so this will be x test scaled, and x scalar, the same scalar, transform x. So after we have done our scaling, we can then do let's say a classification, the conventional way of building a classification model. So I'm going to build a classification model using the random forest classifier. Okay, then from there, then apply the Optuna, use the Optuna library for hyperparameter tuning. So let's build that classification model using the random forest classifier. I'm going to use a function for this. So from defining my function, I'll just call my function as objective. So objective. So this is my function. Then after this, we create a random forest classifier. So create random forest classifier. CLF, just give it a variable. Then from here, you recall this. So you call your random forest classifier. Okay. And after this, then let's create a new cell here and import the cross-val predict function. So from model selection, import cross-val predict. Another thing, cross-val predict. Okay, so we are going to use that. So I'm going to import this model selection from scikit-learn. Okay, scikit-learn.model selection, import the cross-val predict. Then use the cross-val predict get predictions. This step is not necessary, but I like using it, using cross-validation. Because I understand that cross-validation is, if you want to get at least close to accurate scores about your model, then cross-validation is the best way to go. Okay, so why pred? Then you can just do a cross-val predict. Then we recall inside the brackets, I'm going to use CLF. So that's the random forest classifier. Then I recall the X-train scaled data. So I just paste that. Then we are doing train, white train. Then provide cross validation, I'll say 3. That's it. Then after we are done with this, we can then print the classification report. I'm just showing you the convention way, or a way that we usually use to build a classification model. So here we can then print the classification report. So classification report for random forest. We are done with this. We can say, then we say we're going to print the classification report. By train, by plate. So after this, we then add this by calling the function. Function is called objective, so just say objective, then execute it. So when you execute this, we'll be doing, so we have built our random forest classifier, and these are the metrics showing how our model is performing in terms of precision, in terms of recall, and in terms of the F1 score. So you can see how our model is performing. Okay, so as I said, this is just a way of building a classification model. So we will move a step further and trying to improve this model now using the Optuna library. Okay, so I'm going to start by import Optuna. So import. Okay, another thing. So for the metrics, we can use different metrics. We can either use accuracy, we can use the F1 score. But let's see. Let's use F1 score as our metric to measure the accuracy of the model after doing the hyperparameter search. So I'll say so it depends. You can use accuracy, F1 score, the recall, or the precision, depending on the situation or what you intend to use as a metric to evaluate your model. Okay? So from scikit-learn metrics, we're going to import F1 score. You can also import, I think the classification. You can also import the accuracy score. Okay, so that's it. So we can execute this cell to import those. Scikit-learn.metrics. Scikit-learn.metrics supposed to be accuracy score from scikit-learn. Okay, so we have fixed that. Now let's we can also use, let's say, accuracy. Accuracy score. I think it's. I think you're okay now. You're okay. So let's now see how we are going to apply Optuna. Okay? So as I said, we are going to use the random forest classifier. So as we saw earlier in the other techniques, you first have to build something like a search space or the parameter grid. So when you look at Optuna, you can see that you first have to build for a simpler optimization problem, you define the objective function to be optimized, then suggest hyperparameter values using trial object, Here, a float value of x is suggested from -10 to 10. Then create a study object to invoke the optimize method over 100 trials. So in terms of trials, it depends with the number of trials that you are going to use. Of course, I think as you increase the number of trials, so does your model improves. But I remember doing that, it will take quite some time. Okay, so let's see how we can apply that. Because as we saw, you first define an objective function. So let's do that. Let's first define an objective function. So def the objective. What did they use? Something objective. Let's call it objective. So objective trial. So that is an argument. Parameter argument. Then from here, we define the hyperparameter search. Define the hyperparameter to search. So from here, do params and just this. For random forest classifier, definitely we have these are the different hyperparameters. Of course, I'm not going to use all, so I'll just select a few just to illustrate what we are doing. So the first one, n estimators. You trial. So trial dot suggest supposed to be just here we just be passing in integers. And let me say n estimators. Then let's say 10, 100. Okay. This is a dictionary, so remember to add those commas. Then for max depth, again do this again. Trial just here again it's into brackets max depth and say 3, 10. Just copy this. Copy this. Something like this. Then so we just then add the hyperparameters here. So n estimators max depth. Another one will use the minimum sample speed. So min samples. This one, just copy this. This the minimum sample speed. Let's say do 20. Let's say 10. The minimum sample leaf. Just do like this. So for the minimum sample leaf, don't need to, can just, so if you have other parameters, you can just add them here. Any other thing, I think we're okay there. Just do away with this. So after we created that, the next step will be about initializing the random forest classifier. So we initialize that. So initialize random forest classifier. Here rf, I just call it rf model, rf model random forest fire. So this you can then pass these parameters. Okay, so you can pass those parameters around. So this you can then fit the model to the entire training data set. Fit model to training set. So rf model dot fit, and just copy this. Fit extend scale y train. Copy that, paste it in here. Then after this, we are going to make predictions. The predictions, we know it. So y bread rf model dot predict test failed. Then we can evaluate our model. So, and then evaluate our model. And for the model, remember we are creating an objective function. We'll be having issues. We need to make sure our indentation, the indents are okay. Remember, we are operating inside a function. Okay? Then after we're done with this, we can then let's say because Optuna will try to minimize the objective function. So, yeah, so we need for accuracy, because say that since Optuna will try to minimize the objective function. So we return 1.0 minus the accuracy. Okay, so 1.0 minus the accuracy. So this is how we create our. So this is the first step about creating the objective function. So let's move to the next step, which is about. So I think we have done these two. We have defined an objective function and suggested the hyperparameters for that. So let's move to the third step, which is about creating a study object to invoke the optimize method for over the n number of trials we will decide. So let's create that. So I'll call this a study underscore accuracy. Study accuracy to Optuna get study. Then direction, here we try to minimize that. As we saw earlier, we are trying to minimize. So you can either minimize or maximize depending with I think the metric that you're using. Varies with the metrics that you are using. Then study dot accuracy, study accuracy. So we try to optimize. So here we optimize. So what are we optimizing? The objective function, this one, the objective function that we created. So Control C, just paste it here, objective. Then we supply in the number of trials. The number of trials, you can do 100, but for ease of time, let's use 25. Then you want to show the progress bar. So progress bar, how the training is occurring, the progress of the training. So use true so that we'll be able to see that. So when you execute this, we execute this, and then we execute this. We're getting at some errors. 0 failed parameter. Name TL is not defined. Trial. So what are we missing? The accuracy dot optimize objective and trial show progress bar, direction minimize, dot create studies. Trial. Oh, this one supposed to be trial. Trial. Okay. Spellings. Okay. So we can execute. Because the training is taking place, and then move to another step. Let's do some printing. So we print. So number of finished trials. Let's call this accuracy. Finish accuracy. Then this. Now the length of study accuracy dot trials. That's it. So we are done with that, and then print paste trial accuracy. That's it. So trial accuracy goes to study accuracy. So here basically we are trying to determine the best trial accuracy is equals to study accuracy. That's okay. Then we can then print generally the values. This will be the accuracy, the value for accuracy. So trial accuracy dot value. Okay. So basically here, what we are doing is that we are printing the accuracy of the 1 minus accuracy value. Okay. So after we're done with this, we can then print the parameters themselves. So params do this, then for the parameters we're going to use the for loop. So for key comma value trial accuracy for key comma value trial accuracy. So for key value trial accuracy, it's supposed to be value in trial accuracy. So for key value in trial accuracy, so we're going to use params dot items. Print, going to print, these are just placeholders. The key and the value we are going to print. Format that we're going to take, that's the key and the value, key and value. Okay. We execute this. So when we execute this, number of finished trials for the accuracy is 25, just as we set the number of trials. Okay. Then after that, the best trial accuracy, is this. This is the value of the accuracy, 0.77. So let's try about 50. Let's try the trials and see what we will get. So when that is running, we can then use the best hyperparameters that we have searched to try to build the new model. Okay. So here we are using the best hyperparameters create and evaluate the final model. Because this is a necessary step, because after getting the hyperparameters, you can now see the value we are getting here has increased to about 80. So you can see the difference for that. So after getting the best hyperparameters, I think it's necessary to use the same hyperparameters to now try to build the final model. Okay. You can pass in the parameters as arguments inside in something like after creating the initialize the random forest classifier. So ideally, after getting the parameters that you need, you can start by initializing the random forest classifier, and by this you'd start the process of then doing this and copying and pasting inside these brackets again and again. But I want to use a shorter method, okay? That will save you time, okay? So best params for accuracy. So we'll just do a trial accuracy dot params. So basically this variable, when we do something like print this, so this variable will contain a dictionary of the parameters as well as the key values. Okay, so this one is very important because it's going to save us time for keying those parameters individually into your final model. Okay, so then the best is a random forest model. Best random forest model. So you can call the random forest classifier. Call the random forest classifier. Then you can then pass in an argument best random accuracy. Okay, pass this argument. Then for example, if you want to use the random state, but it's not necessary. But if you want to add that, you can do that. So after creating our random forest model, creating an instance, and for that, and passing in the best parameters that we got, we can then use this model now to do the fit. So we're going to fit this on the xtrain held again ytrain. We are fitting this into our training data and we supply the labels for that. When we are done with that, after doing the fit, we can do the prediction. So y bread so we again just recall this, Control C, Control paste, and we are going to do the y bread using the xtest scaled. Then after we're done with this, and determine let's say new RF model accuracy score. Just do y test in April RF. So after done with this, we can then now print accuracy this. Try to use definitive variables because getting y10 is not defined. So it's supposed to be y train, not y10. Okay. When execute, and the random forest classifier object is not callable. Underscore accuracy params base param. So y bread RF best RF model dot ops forgot dot predict. When we do the predictions, this is the This is the results we are getting. Okay, accuracy. Point 77, 0.79. Okay, so 0.78, but we got a little bit higher accuracy for the training. Okay, and this one is for the, so we're not badly off. Okay, but basically you can now see how we can apply Optuna given a classification example. For example, if you want to use another scoring techniques, for example, let's say the F1 score as you are scoring as a metric. If you want to use F1 score for that, again, we just do the same thing. It won't be something different. You can just copy this and paste it here. So the small thing that you're going to change will be the F1 score. So this one, the parameters will remain the same. RF model, this will remain the same. RF YPRED, and the predict on the X test scale accuracy. So this is what you're going to change. So we'll call F1 F1. So we use the F1 score, F1, and this one remains the same. Then return a negative F1 score for minimization. Here we're going to return negative F1 score for mini again. So return, you can say we are going to return minus F1. That's it. When you execute that, again we come to this. You can just copy this. No. You need to create a study. So Control C. Then you can just paste it here. So for study, you can just say call it, instead of accuracy, you can just call it F1. So F1. Optuna create study direction is to minimize. Again here, study no. Direction, this is the direction, either to minimize. Okay. So the sampler is also another thing that you can also include at this stage. So for the sampler object that implements background algorithm for value suggestion. If objective none is specified, so if you specified here none, by default it will use the Optuna samplers.ppse sampler is used during the single objective optimization, and class Optuna sampler nsg II sampler during multi-objective optimization. See also class Optuna samplers. Okay, so if you do not supply this, this one is used by default. But if you give the sampler, so let's try it and use. Let's try to use another sampler. So sampler Optuna.samplers seed value for 6. Then a study F1 of optimize objective and trials 50. Then show progress bar true. So yeah, okay. So as this is executing, you can then go back, copy this, and paste here. So number of finished tiles, instead of accuracy, you can just say F1. And study accuracy, study F1. Trials, print based in terms of one. Then base tile F1, that's okay. Trial 1, study accuracy base tile, that's okay. Print this value, we are going to change this. So this one we're going to print F1 score, print the F1 score instead of the negative F1. Okay, print params for key params.items. It's supposed to be trial.f1, not accuracy. Key comma value in trial f1 params, that's okay. Print this format key value. Okay, so this one is okay. Study f1 is not defined. Study f1. So print base trial. So we are in the first this one. I think we define this up here. So study f1, study f1. We have missed something. Okay. F1. Oh, I think this one should be under small letter. Value negative 19. Getting such as yeah. F1, study F1. This one is okay. This one is okay. Yeah, we are getting a value of about 0.70 n estimators, max depth, minimum sample split, maximum sample split. Let's try to increase this to 100. See what we will be getting. So as that is executing, we can then print the base parameters using F1. This one is executing, then we can just, so with the 100 trials, it's going to take some time, but remember we're just having a small data set. So overall, generally this will run quite fast. So currently we are 95, 97, 98, 99, so we are done. So 70, fun score of about 0.655. Okay. So that's it. So you have seen how we can apply. You have seen how we can apply Optuna for a classification model. So next will be, we are going to now apply Optuna, but for a regression model. So we're going to see how we can apply the same for a regression model. Generally, the steps remain the same, but most of the difference will just become in terms of, because remember we are using different metrics for that, so that will change. Also remember for the regression, we are trying to predict a continuous value. So things to do with the final output will also vary, okay? So that's it for now. So that's it for now. So see you in the next one where we apply Optuna given a regression model. Okay.